All right, welcome to AP Biology lecture on Unit 1, Biochemistry. We're going to start out the year in Chapter 1, which is kind of just an introduction to the year, kind of what the types of topics we'll be going through. And so that's what this first podcast is about, is just getting used to the system and kind of how this year is going to work out. There are major themes in biology that run through it, and you probably might be familiar with some of those from your freshman biology experience. But the AP biology curriculum does have some new themes as well, and so some of those themes coordinate nicely with the things that we've done before in the past. Evolution, natural selection is something that we've spent a lot of time on if you've taken biology here at Hartford Union High School in the past. Big idea number one is the process of evolution drives the diversity and unity of life. So that is one of the big themes that should go throughout the year. We will be touching on it throughout first semester, but we won't get into kind of reviewing some of the specifics on evolutionary theory, big names in evolution, as well as the specifics of natural selection, probably more into second semester. Another big theme that runs throughout biology is the idea of homeostasis. We touched on this in freshman biology, the concept that dynamic equilibrium is the way that cells, the body, all living things try to maintain some sort of balance, but in an ever-changing world and ever-changing conditions. So dynamic means always changing, equilibrium means trying to maintain that balance. And the AP people have come up with big idea number two, that biological systems utilize free energy and molecular building blocks to grow, to reproduce, and to maintain dynamic homeostasis. So that dynamic equilibrium concept is at the end there. We will be touching on throughout the year what Gibbs free energy is and how that relates to this. We'll be starting out relatively shortly here with molecular building blocks tying into some of your chemistry prerequisites. We'll get into reproduction and development and that kind of thing as well as we go throughout this year. But big ideas, all of those things come into play to maintain homeostasis. Our freshman biology stuff went through energy, matter, and organization. We maybe shortcut it with saying EMO. Energy ties into that big idea number two as well with the Gibbs free energy. Matter deals with all the building blocks that are necessary to grow. And then the levels of organization is just how all that stuff stays together. We have this concept of a one-way flow of energy, and this graphic here will show us that all the energy comes to us from the sun. There are a few variations of this we can get into later, but the producers, the things that produce energy, will trap that sun's energy, convert it, and use that energy as their own from the sun. And so we call those things producers. They then take that energy and pass it on to other things, things that consume it. So the producers pass on their energy through this arrow to the consumers, and then consumers can get broken down by decomposers, and they can also decompose the producers. So the energy can go from the producers to consumers and decomposers. Sometimes in the middle of that, nutrients are cycling, but the actual energy is passed on, passed on, passed on, and eventually that energy is transferred or sometimes transformed into other forms out into the system, and not staying in the living things of producers, consumers, and decomposers. And so we see that energy is constantly moving, and we'll learn in the next unit that energy cannot be created nor destroyed, but is constantly transferred and transformed. And so we'll come back to that idea in the not too distant future. We also, when we talk about the matter piece of things, there are 92 naturally occurring elements, 22 of which occur regularly in living organisms. But then there are more things on the periodic table of elements that are not natural. And so those 22 occurring, here's an example of a couple of those things. If you see something here in terms of the Earth's crust, oxygen is very, very common in the Earth's crust along with silicon. And why those two things are very, very common is because together they make up something called silicon dioxide, and sand is made out of silicon dioxide. And so all the components that come from sand go into that. And so the Earth's crust is made up of mostly silicon dioxide, and then there are obviously some other metals and minerals and things like that that are found in Earth's crust, but a huge portion of it is in the form of silicon dioxide. I'll jump over to the other side here. Pumpkin, it says 85% oxygen and 10.7% hydrogen. Now over here on the side, got a little note here. It's percent weight, so it's not by mass. It is by mass percent weight rather than by exact amounts. This is obviously because a pumpkin is mostly water, H2O. The hydrogens, though, weigh much, much less in terms of atomic mass units than the oxygen weighs. And so it's got a greater mass of oxygen just because of the large amounts of water, even though there are twice as many hydrogen ions. I think if you remember back to your chemistry, the oxygen would be somewhere around 16 atomic mass units, and the hydrogen would be at 1. We as humans, we have a little less oxygen, and then there is a similar amount of hydrogen, but we add some more carbon to the mix. You can see carbon is a component of pumpkins as well. When it comes to the actual elements in living things, we oftentimes, let's see if I can write this, actually switch to pen. We as living things are made up of, where is my pen? There it is. We are made up of H, hydrogen, oxygen, nitrogen, and carbon. Those are the biggies, and I kind of remember it as HONC. Hydrogen, oxygen, nitrogen, and carbon are some of the things that we will find a lot of as we go through this. We have the oxygen, we have the carbon, we have the hydrogen, we have the oxygen. Those are our big four in humans, and you can see in a pumpkin it's similar. Potassium just edges nitrogen out, though, getting into the top four. But if you consider all living things as a whole, typically the top four are hydrogen, oxygen, nitrogen, and carbon, in no particular order, just that it reminds me of the word HONC, and it's something I can use to remember that.